Here we go, starting chapter 4, section 1, powers and exponents. We're going to be learning about powers and exponents today. First off, a bit of vocab. An expression like 5 times 5 times 5 with equal factors can be written using an exponent. An exponent tells how many times a number is used as a factor. Go ahead and underline this. That is your definition. An exponent tells how many times a number is used as a factor. A number that is expressed using an exponent is called a power. Again, that's a number expressed using an exponent. And then the number that is multiplied is called the base. So your base is our factor. So equal factors. So 5 times 5 times 5 equals the power 5 to the third. Just a little bit of visual over here. 5 to the third. R3. We're going to label that as our exponent. The 5, our factor, is a base. And then the whole thing together is our power. Alright, so a little bit of practice writing expressions using exponents. If we have negative 8 times negative 8 times negative 8, well, our equal factor, our base, is negative 8. And then our exponent, you see we have 1, 2, 3 negative 8, so our exponent is a 3. Now notice we have our negative 8 in parentheses because it is a negative number. If you're unsure, put it in parentheses. Right, part B, k plus 2 times k plus 2 times k plus 2 times k plus 2. Well, this time our factor is the quantity k plus 2. It's the whole piece, so we need to put it in parentheses. And how many do we have? 1, 2, 3, 4 of them. So k plus 2 to the fourth. And last up, 5 times r times r times s times s times s times s. Okay, so we have 1 5. We have 2 r's, so 5 times r squared. And we have 1, 2, 3, 4 s's times s to the fourth. So 5 r squared s to the fourth. And that's a little practice just rewriting. Now evaluating. Evaluate each expression if a equals 5, b equals negative 2, and c equals 3/4. Well, we know for evaluating, our first step is to substitute. You must show your substitution. So 10 plus, in parentheses, b is negative 2 squared. So 10 plus, you can do this on your calculator, but negative 2 times negative 2, we know 2 negatives makes a positive. 2 times 2 is 4, so 10 plus 4 gives us final answer of 14. Next up, again, show your substitution. A is 5 plus B is negative 2, so I'm going to put it in parentheses. Whole quantity raised to the third. Right, we do inside parentheses first. Remember your PEMDAS. 5 plus negative 2, same as 5 minus 2, gives us 3 to the third. Now you can do this on your calculator with the caret key, or know that that means 3 times 3 times 3. So 3 times 3 is 9, times 3 gives us 27. And our last one, 2 minus 3/4 squared. Okay, when we're squaring a fraction, you square the top, so 3 squared, 3 times 3 is 9, over, square the bottom, 4 squared is 16. We need common denominators, so 2 over 1 minus 9 over 16. We're going to take this one times 16 times 16, so 32 over 16 minus 9 over 16, 32 minus 9 gives us 23 over 16, and running out of space here. We know we don't like improper fractions, so squeeze this in wherever you can. Final answer is 1 and 7/16. 1 and 7/16. Okay, moving on. What is the value of the expression 6a to the third minus 1/9 b to the fourth if a equals -2 and b equals 3? So again, we show our substitution. 6 times a is -2 to the third power minus 1/9 times b is 3 to the fourth power. Okay, we're going to take care of exponents first. So 6 times, the only thing raised to the third power here is our -2. So -2 times -2 times -2 will give us -8 minus 1/9 times 3 to the fourth. So 3 times 3 times 3 times 3 is 81. Since I have a fraction here, I'm going to go ahead and make 81 into a fraction as well. And now we're multiplying. So 6 times -8 is -48 minus 1/9 times 81 over 1. Okay, well, I know I can reduce here. I have a 9 in my denominator. 9 divided by 9 is 1. 81 in my numerator. 81 divided by 9 is 9. Okay, so 1 times 9 is 9. 1 times 1 is 1. So 1/9 times 81 is just 9. Again, you'll have your calculators to do some of these steps. And then 48 minus 9, -48. So -48 plus -9, both negatives. So final answer of -57. All right, a little watch out post-it note here for you. -3 squared in parentheses is not the same as -3 squared without the parentheses. In this first case, the negative is also being squared, so it's -3 times -3. We know a negative times a negative gives us a positive 9. In our second situation, whoops, got it on spot. Second situation, the negative is outside the square, so that's negative times 3 times 3. In this case, we only have one negative, so that would be -9. Please watch your negatives, especially when you are using the calculators. All right, we want to compare some numbers. So 2 to the 5th compared to 5 squared. Well, 2 to the 5th means we have 2 times 2 times 2 times 2 times 2, which is 32. 5 squared, 5 times 5 is 25. So this is greater than. Move over here, 3 to the 6th. 3 times itself 6 times would be 729. Compared to 6 to the 3rd, so 6 times itself 3 times. It's 108. Again, we have a greater than. Now -6 to the 4th. Negative is inside, so that negative is also being raised to the 4th. Would be 648. Positive 6 to the 4th is 648, so this one is equal. And then -4 to the 6th. Again, we have an even power with a negative, so it is going to be a positive number versus negative to an odd power. If I have an odd number of negatives, that's going to be a negative number. I don't even have to figure out what the numbers are. A positive will always be greater than a negative. Now, if you saw this on a test question, actually figure out what the number is. All right, last thing for this section, we want to figure out some patterns here. So going from 5 to the 4th to 5 to the 3rd. Well, 5 to the 4th is 625. 5 to the 3rd is 125. What we're doing here is dividing by 5. 5 to the 3rd to 5 squared, so 125 to 25. Again, we divide by 5. 25 to 5, we're dividing by 5. So how would we go from 5 to the 1st, which is just 5, to 5 to 0? Well, if we divide by 5 again, 5 divided by 5 is 1. Okay, so our rule here is our any number raised to the power 0 will be equal to 1. Anything raised to the 0 power is equal to 1. So some examples here. 7 to the 0 is 1. X to the 0 is 1. 7,568 to the 0 is 1. And if you saw this big complicated 3x, y, z plus 82x squared z to the 10th whole quantity raised to 0, it is still 1. Anything raised to the 0 power is 1. Right, that is our first lesson.